This problem is from Chapter 1, page 22, number 54. Potassium sulfate has a solubility of 15 grams per 100 grams of water at 40 degrees Celsius. A solution is prepared by adding 39.0 grams of potassium sulfate to 225 grams of water, carefully heating the solution and cooling it to 40 degrees Celsius. A homogeneous solution is obtained. Is the solution saturated, unsaturated, or supersaturated? The beaker is shaken and a precipitation occurs. How many grams of potassium sulfate would you expect to crystallize out? So first, let's underline what we know. First, we know that there is 15 grams of potassium sulfate per 100 grams of water at 40 degrees Celsius. So we wrote that here. Second thing we know is that a solution is created by adding 39.0 grams of potassium sulfate to 225 grams of water. So we wrote that here. To start, we need to solve the first part, which is asking us if the new solution is saturated, unsaturated, or supersaturated. So the first thing we're going to do is work with some fractions. So first we know that it's 15 grams of K2SO4 over 100 grams of H2O. And that's going to get us 0.15. And then we have 39 grams of K2SO4 over 225 grams of H2O, which gets us 0.17. So the 0.15 is considered the solubility constant of potassium sulfate. So we know that number is considered perfect. So comparing it to the 0.17, 0.17 is greater, which means that when in a beaker it's going to have too much of the potassium sulfate compared to the water, so it's going to be supersaturated. We also know this because the next sentence in the problem is the beaker is shaken and a precipitation occurs, which also proves our point that it is supersaturated. The next question we're going to solve in this problem is how many grams of potassium sulfate would you expect to crystallize out? So we're going to build an equation off of these fractions again. So we know that here to the right that it's 15 grams of K2SO4 over 100 grams of H2O. And then on the left, we're trying to figure out how much potassium sulfate is going to crystallize out. So we know that the ratio that we used up here, there was too much of it, and that's why a precipitation reaction occurred. So we're going to figure out what needs to be subtracted or taken out in order to get the perfect ratio, and that X is going to tell us how much will actually crystallize out. So our beginning equation we're going to start with is 39 minus X grams of K2SO4 over 225 grams of H2O equals 15 grams of K2SO4 over 100 grams of H2O. So now we're going to do some algebra and we're going to do some cross multiplication. So we do these, the top and the bottom multiplied together, and then the other top and the bottom multiplied together. And for now we're just going to put the units to the side to make it easier to see. But we have 39 minus X times 100, and then 15 times 225. And then we go down to the next level, and that gets us 3,900 minus 100X equals 3,375. And then we're going to subtract 3,900 from both sides, getting us negative 100X equals negative 525. Next, we're going to divide both by negative 100, which gets us X equals 5.25. But now units come back. We can't forget about the units. So that would mean that since X is the number of grams of K2SO4 that crystallized, it's 5.25 grams of K2SO4 that will crystallize. Did you think you were done? Not yet. We can't forget about sig figs. So in order to figure out how many sig figs we're going to use in the final answer, we have to find the least amount of sig figs in the entire problem. So looking around, the least amount in the entire problem would be 100, because 1 The number 1 is considered a significant figure, but both the zeros after are not, which means the least amount is 1 sig fig. So our 5.25 is going to turn into 5 grams because of this. So our final answer would be 5 grams of K2SO4 will crystallize out in this solution.